Okay, I think the easiest way to answer this question is just by making a short video for it. So let's start. Okay, Kayla. Let's read what we've got here. Okay. Yes, semester is going well. That was not the reason why I'm making this video to reply to that. Okay, so we're going to be talking about total reserves and how the reserve requirement works. So let me talk about the theory first, and then we'll go to the specific question. Going here. Okay, so what we're talking about in general in this chapter is the idea that the Federal Reserve does part of the work to change the money supply, but that the fractional reserve banking system does the majority of the work to change the money supply. So changing the money supply. Obviously, when it's increasing, that's expansionary policy. I know this is more info than you requested, but and if the money supply is falling, that would be contractionary monetary policy. And the reason why you would use expansionary monetary policy is if your aggregate demand curve and your long run aggregate supply curve, if it was to the right, of the short run equilibrium point. So this point A would be the short run equilibrium point. But what we can see here is that Q1 is less than Q star, where Q star is the long run. So we need to basically increase the money supply to reach the long run equilibrium. That would be expansionary monetary policy. So you would increase the money supply to basically shift out the aggregate demand curve from A to B. Now, what this question is trying to get at is how much do I need to increase the money supply by? Okay, so basically what we're saying here is that to go from AD to AD prime, right, that shifting of the aggregate demand curve, how much do I need to increase the money supply by to get that change? Well, in essence, I need to know what the difference is between Q1 and Q star. I'm going to make up some numbers here. Let's say that's 100 and that's 60. Making the numbers up. Okay, so what my goal is a 40, let's say million, a $40 million increase in the equilibrium. The idea here, and this is the important part, so I don't know what minute mark this is in the video, but this is an important point right here. if the difference between these 2 points is 40, the point of your question is that the Federal Reserve, the central bank, doesn't need to print all $40 million. Rather, it only needs to print a fraction of that amount in order to push the economy to be. To know what that fraction is, that's where we need to know things like the reserve requirement, and then calculate the multiplier and go from there. Okay, so now let's go to the question. Okay, so we got a reserve requirement of 25 and a reserve requirement of 10. And in both cases, we need to calculate the simple deposit multiplier or simple money multiplier. Okay. So when the reserve requirement is 25%, the simple deposit multiplier, the simple money multiplier is 1/1 minus the required reserve ratio. Or in this case, 1/1 minus 0.25, which is 1/0.75, which is equal to 1.33. Now, what that then requires here is that we're now going to make a comparison to what happens when the reserve requirement is 10%. Now, what this starts to tell us is it starts to give us an idea of um, how much um, how much I need to change things by. So now what we can do is um, now so now in the lead up, um, what this part does up here is it gives us an idea of the ratio of what the Fed does versus the banking system does. You don't really need to do this calculation. I just sometimes find it useful just for my own purposes as a way to double check things. But now, what the question specifically is asking for in MindTap is the um, simple money multiplier. So, what that is, instead of 1/1 minus the required reserve ratio, which again is giving us that kind of fractional um, distribution between what the Federal Reserve needs to do versus the banking system. What the what MindTap is asking for is really right here. So what is this telling us? Let's go back to our goal, my made up goal here. My made up goal was that I needed a $40 million increase. But if the required reserve ratio is 25%, then the multiplier is 4. What does that mean? For every dollar the Fed adds to the money supply, the money supply changes by $4. In essence, the fractional reserve banking system is adding $3 through the act of continually lending out money. And what does that mean? Let's say the Federal Reserve prints that first dollar. It can't just print it and like put it into the banking system. It has to do something with it. So one of the things that the Federal Reserve often does is it buys or sells an existing piece of government debt. In this case, if it's doing expansionary policy, it's going to be buying existing debt. So let's say that I, Tom, own the debt, and the Federal Reserve is going to buy $1 of the debt that I own of the federal government. The Federal Reserve is going to pay me that dollar, and I'm going to put the dollar that I just got into the bank. So Tom's bank is going to go up $1, but the bank will make a loan for 75 cents to someone else. And the reason why is because the required reserve ratio is 25%. So some other person is not going to be able to make a 75-cent deposit. And that bank is going to lend out 75% of 75%. And then that process would keep going on and on and on until $1 becomes $4. So what that means for this issue right here, if the goal is to push the economy $40 million and the required reserve ratio is 25%, then the Fed only needs to add $10 million. Because the other 30 million is just going to come from banks lending out the money. Okay. So that takes care of the second column, simple money multiplier. To simplify the analysis, suppose the banking system has total reserves of 500. Determine the money multiplier and the money supply. Okay. So what we know is that if the reserve ratio is, let's just look at 10%, 10, 5,000. Okay. Okay, so now if the money multiplier is 4 because of that 25% rate, then 4 times 500, which is the amount in reserves, is equal to $2,000. When we hit a 10% required reserve ratio, the money multiplier is 10. We know that because we saw that up here. So that would mean 10 times 500 is equal to 5,000. And I think that takes care of that. So then the lower reserve requirement is associated with a larger money supply. And we can see that in the graph that is true. So now the last part. Suppose the Federal Reserve wants to increase the money supply by $200 and the reserve requirement is 10%. Then they're asking what will the open market operation do? The open market operation being the buying and selling of existing debt. If they're going to increase the money supply by 200, they're going to be buying the debt. So you chose the right option here. But they're not going to buy $200 of bonds. They're actually only going to buy a fraction of that. If the reserve requirement is 10%, they only need to buy a tenth of that. In other words, 20. Then that 20 would be multiplied by the 10, the simple money multiplier, to get you the 200. Okay, I think that takes care of that.